So, starting with the topic of transformer, if we talk about the electricity system in our houses or in our society or in our town, if you observe a large PMT on the pole located in every area, every society, after short distance, so that is known as transformer. And the purpose of transformer is to increase or decrease the potential difference or the voltage, right, of an alternating current. Because in our houses or in the circuits where AC circuits are included, so when there will be a flow of alternating current, so we use transformer to increase or decrease the value of potential difference in the circuit, right? So we can write as transformer is a it is a device that can be used to increase the difference and AC alternating current, right?
Okay.
So this is the main purpose of transformer, to increase or decrease the potential difference. Or if we talk about the construction and the components of the transformer, so if we talk about their components, so components will be like this. There will be primary coil, will also be a secondary coil, and soft iron core. And let's see how these components are to be connected in the circuit. This is the structure of soft iron core, right? Let's suppose if there is a rectangular coil and there is a gap between this coil and this part is wounded with a wire. There will be a loop of wire on left hand side and there will also a loop of wire on right hand side. Okay. And the center part is hollow. There is no connection, or you can say that there is no direct connection of these wires on left hand side or on right hand side. Okay. And the primary and secondary coil are known as, this left one is known as the primary coil, or you can say that where when current is start flowing from the circuit, or there will be a value of input there, so the input part or the input value is known as the primary coil. So this becomes coil and right will be a secondary coil. Okay. And you know that when there will be a current or there will be an electric current flow through the conductor, so there will be a magnetic field around the wire, right? The first concept we discussed in our chapter, the magnetic field around the current carrying conductor. So when current start flowing through the loops of the wire, so there will be a magnetic field around the wire, right? So let's suppose magnet going to produce over here. So there will be magnetic field, and this works like this, that current will only flow through the primary coil, right? There will be no flow, or there will be no connection of electric current through secondary coil. So the value of electric current produced in secondary coil with the help of induced EMF, right? Because there is a change in magnetic field. So due to change in magnetic field, there will be a value of induced EMF in the secondary coil. The same concept we discussed in the start of the chapter, that there will be a value of induced EMF due to change of magnetic field, right? So that's why we use two wires of different combinations, and there will be also a number of turns that depends on the value of potential difference in the circuit. And there are two type of transformers. If we talk about type of because there are number of loops over there, so we need to know about the reason that why there will be a number of loops or number of turns in wire over there. So we talk about type. So first type is known as step transformer, and second one is known as step down transformer. And the working of a step up transformer is to increase the output voltage, right? And if you thought that how is it possible in a step up transformer? So first talk about up transformer. Basically increase the potential difference. It increases the potential difference of our source. It means that there is a 10 volt, uh, there will be a value of 10 volt in input. So that will be increased to 12, 13 or 15 volt. So that is the purpose of step up transformer, to increase the input voltage or input power, right?
Yeah.
How it is possible? That is the function of transformer. We can increase the value of potential difference on output by increasing the number of turns, or you can say that number of turns in the loop of a wire that is connected on the secondary setup, right? So this can be done with the in the secondary. So the number of turns later, right? Or in simple or mathematically, we can say that number of turns in secondary coil will be greater than turns in primary coil. And if we want to demonstrate them into diagram, let's suppose we turn on the primary coil. So this will be the primary coil. Okay.
Yes.
So by increasing the number of turns, we can increase the value of the potential difference in the output, because there is no other factor which is going to be included over here. So the number of turn is the most important factor in the transformer, right? And if we talk about the second type of transformer, that is a step down. So the step down transformer is to decrease the value of potential difference, right? Let's suppose if there is a value of input voltage is equals to 20 volt. So it will decrease the value to 15, 16, or less than any value which will be less than 20 volt, right? So it will decrease the potential difference of power. और सेकंड पॉइंट क्या हो सकता है यहाँ पर, नंबर ऑफ टर्न्स कहाँ ग्रेटर होंगे?
In the primary coil?
In the primary coil. Number of turns will be greater in primary coil. Actually, we can write E will be greater and और ग्राफिकली और डायग्राम फॉर्म में भी आप इन्हें ड्रॉ कर सकते हैं. Draw greater of turns as compared to the secondary, right? So this is the function of transformer to increase or decrease the value of the voltage or the power source that is going to be transferred from primary to secondary coil, right? Any confusion?
Yes. No, it's clear.
Okay. So if there will be some questions related to the ratio of the number of loops in the coil or related to the transformer, that there will be a value of voltage given. So we can also calculate the values which are related to transformer. And let's talk about the formula which we are going to use for transformer. Let's suppose if we consider an ideal transformer. Ideal transformer, that there will be no loss of energy over there, or energy, all the value of power sources are conserved. So in this form can be written as, so this is the formula, that the voltage of secondary multiplied by voltage of primary is equals to number of turns in secondary multiplied by number of turns in primary. Or you can also write this formula as voltage of secondary coil divided by the number of turns in secondary coil and number of turns in primary coil divided by the voltage in coil, right? So you can also write this formula like this, or otherwise you can write as, or it's your choice how you're going to write this formula. It's up to you, right? Any confusion?
No.
So these are the formula which we are going to use in our questions, or we can also use the formula that voltage primary coil divided by secondary is equals to number of primary coil divided by number of secondary. So in our next class, when we are going to solve the question, then we will discuss about the formula and the conditions which we are going to use in our questions of transformers and electromagnetic induction, right?
Yes.
because V is the value of potential difference, and if we are going to use Ohm's law, so it is also equals to IR if there is a required value, but there will be no required such value for Ohm's law to substitute in this equation. So this formula will be very easy to solve in the practice questions. So from next class, we are going to solve the past papers questions of this whole section. Then we will start our new section. Okay. So this will be the end of this electromagnetic induction, right?
Okay.
So inshallah, we will meet in our next class.